Hello and welcome back. I am Benjamin Williams, and today we're still within the infrastructure section within Boson NetSim. Today we're going to be doing a lab on many-to-one NAT. So let's go ahead and get into our lab objectives for this lab. So it says, learn the basic commands needed to configure many-to-one network address translation NAT on a Cisco network. Configure the routers with routing information protocol version 2 v2 so that all devices can ping any other device. So here's our lab topology that we're working with in this lab. As we can see, we have host A. It's connected off of the 192.168.101.1/24 network. We have a serial connection over to router 2, and this network between these two routers is the 192.168.1.1 or 1.0/24 network, and it's a serial connection, as we can see. So either a PPP or HDLC encapsulation is going on. We got a point-to-point connection right here. And then from router 2 to host B, we can see that it has a network of 192.168.100.0/24. So we've already read through all of the commands and also the descriptions for this lab. So we're going to do the normal. I'm going to keep my lab topology up here in the top left. We're going to be doing all of our lab readings from the top right, and we're going to be doing our CLI configuration down here at the bottom. So let's go ahead and get into our lab task for this lab. And let me not forget, I did read through all of the IP address information and just confirm that everything looks good. And it's always good to have this as a reference when we're labbing up or when you're troubleshooting in general. You want to have that IP address information so you can confirm certain details. So let's go ahead and get into our lab task. It says configure router 1 with a host name of router 1. Okay, so let's do that first. So we already have our first instructions. So let's do a enable a configure terminal conf t, and let's change the host name to router 1. Perfect. Now we can see that we have a host name of router 1 right there. So that's looking good. It says configure the appropriate IP addresses on the interfaces. Refer to the IP addresses table. A DCE cable is connected to router 1. The serial link should have a speed of 64 kilobits per second and enable the interfaces. So it wants us to do our IP address information for router 1. And we can see our IP address information is up here in the top right. So let's configure first the fast Ethernet 00 connection that connects out to host A. So let's do a interface fast Ethernet 00, and let's give the IP address. As we can see, it has an IP address of 192.168.101.1 and a /24 net mask. So let's do 192.168.101.1, and we're going to do 255.255.255.0. Say enter. Let's do a no shut, and we can see it changed to up, so that's looking good. So let's do an exit, and let's go ahead and configure the serial 00 interface next. So let's do an interface serial 00. All right, and we want to give it an IP address of 192.168.1.101, and it also has a /24 net mask. So 192.168.1.1, and we want to do a 255.255.255.0. And it also says a DCE cable is connected to router 1, and it said its speed should be 64 kilobits per second. So let's confirm the speed. So let's give some context sensitive help, and let's do a what is the command to do the speed? Clock. Yep. So clock rate is going to be 64 in kilobits per second. That means that we're going to have 3 zeros. So 64, 1, 2, 3 zeros. All right, and let's give a no shut here. And we can see that our serial 00 interface just changed to the up state. So everything looks good so far. It just changed to the down state because I believe we haven't configured the IP address for router 2 yet. So as soon as we configure that interface, it should stay in the up state. Okay, so let's go ahead and move on to number 2. It says configure router 2 with a host name of router 2. Okay, so let's go ahead and pull up router 2. And let's close down host B. We don't want that just yet. So let's go to router 2. We're on router 2 now. Let's do an enable. Let's do a configure terminal to go into global config mode. And let's give a host name of router 2. All right. Perfect. Now it says configure the appropriate IP addresses on the interfaces. Refer to the IP addresses table and enable the interfaces. So we can see that we have an IP address for the fast Ethernet 00 of 192.168.100.1, and it has a /24 net mask. And for our serial 00 interface, we have the IP address of 192.168.1.2, and it also has a /24 net mask. So let's first do the fast Ethernet 00 interface. So let's go into interface fast Ethernet 00. All right, let's give the IP address of 192.168.100.1 and the 255.255.255.0 for that /24. Let's give a no shut to bring that interface to the up state. Let's do an exit. Let's go into interface serial 00 next. We want to give it an IP address. We can see its IP address is right here, 192.168.1.2. So 192.168.1.2. It has a net mask of 255.255.255.0. So that's /24. And let's do a no shut to bring that interface to the up state. All right, so I think we're good for instructions number 1 and also 2. So next it says configure the routers with RIP. Do not advertise router 1's fast Ethernet 00 network. Okay, so let's start on router 1, and let's do an exit, and let's go into router RIP. Okay, and let's configure version 2 because we want to use RIP version 2 instead of version 1. Okay, and it says to advertise the routes, but it does not want us to advertise router 1's fast Ethernet 00's IP address. So let's just do a do show IP interface brief so we can have this as a reference, and we do not want to advertise, like it says, this fast Ethernet 00 interface. So let's just advertise the serial 00 interface. So let's do a network of 192.168.1.0. Okay, so we can advertise that serial 00 interface. And let's go over to router 2 and let's configure it to run RIP as well. So let's do a router RIP. Okay, let's do version 2, and let's do a network of 192.168. Let's do a do show IP interface brief so I can see what we're working with for our network. So let's do a network of 192.168.1.0. All right, let's hit enter there, and we should have a neighborship come up here in a second. But also, it doesn't say that we're not supposed to advertise the fast Ethernet 00 on router 2. So I'm guessing we need to do that. So let's do a network of 192.168.100.0. All right, and let's do a we can do a exit, or we can even do an end, and we can do a show IP protocols. All right. And we can see that the networks that we're advertising right here, which looks good. It does look good. So I think everything is looking correct as I'm looking. We can see that our interfaces, we have received two hellos, and we also have received two hellos on our fast Ethernet 00 and also our serial 00 interfaces. So everything looks good. Okay, so let's go down to our next instruction. It says on router 1, create an ACL 12 to specify interesting traffic that will be used to configure many to one NAT. So let's go over to R1. And first it wants us to configure the ACL 12. So let's do an exit. Let's do an access list of 12. And we want to permit the 192.168 it says specify the 192.168.101.0/24 network as the source of the traffic. So 192.168.101.0, and we want to do a /24, so it's a 0.0.0.255 because we're using that wildcard mask. Let's hit enter on that. And it says host A is currently connected to router 1's fast Ethernet 00 interface. However, to external devices, host A should appear with the IP address of router 1's serial 00 interface. Okay, so we know that. So let's go into interface fast Ethernet 00. And we know that this is going to be our IP NAT inside, because this is going to be the inside portion for host A in router 1, from router 1's perspective. And we can do an exit, and we can go into interface serial 00, and we can do IP NAT outside here, because that's our outside NAT. And then after that, we can do an exit, and we can do a IP NAT inside. IP NAT inside. We want to do a source list of 12. And we want to do the interface of serial 00. And we want to overload our serial 00 interface. So that looks good. So it says from host A to host B. It says ping from host A to host B. So we see that host B IP address is 192.168.100.2. So it says to populate the NAT translation table and verify your configuration of RIP version 2. The ping should be successful. So let's load up host A. We're on host A now. And it wants us to ping host B, and host B has an IP address of 192.168.100.2. See if we can ping, and we can. We're getting replies from host B. So it looks like everything is configured correctly. So it says on router 1, issue the show IP NAT translation table to verify your NAT configuration. All right. So let's do it in, and let's do a show IP NAT translations. And we can see that host A's IP address is inside global IP address is 192.168.1.1. And it's inside global. I'm sorry. It's inside global IP address is 192.168.1.1, and that's that serial 00 interface or router 1. And the inside local IP address for host A is 192.168.101.2. So that's host A's IP address. And we can confirm that on host A. We can do a IP config /all. And we can see its IP address is 192.168.101.2. And we just confirmed that over here for our inside local IP address. And its inside global, like I said, is 192.168.1.1. And that's that serial 00 interface. So everything is looking correct. So let's go ahead and hit grade. Hopefully we did everything right. And we did. So thank you guys for watching this one, and I'll see you in the next one.